Hello everyone. Today we'll teach you how to write the explicit form and recursive form of a geometric sequence. The recursive form of geometric sequence is an is equal to r a n minus 1. So this is the recursive form where r is equal to the common ratio an is the nth term. So to better explain this, we're going to have an example. 2, 4, 8, 32, 128. So in this example, we're going to use the recursive formula to find the fifth term. So in this formula, we must first find the common ratio. So in order to find the common ratio, all you have to do is to divide this term to the previous term. So for example, 8 divided by 2 is 4. 32 divided by 8 is also 4, and 128 divided by 32 is also 4. So therefore, their common ratio is 4. So in the formula, r is 4. And since we're in this example, we are finding the fifth term, so we're going to change the n here into 5. And in here, a 5 minus 1. So that is 4 times the fourth term. So 5 minus 1, 4. So we're going to substitute the fourth term in this sequence here. Which is, the fourth term is 128. So if you multiply 128 and 4, it becomes, if 128 times 4 is 512. So therefore, the fifth term is 512. So next is the explicit form of a geometric sequence. So the explicit form of a geometric sequence is an is equal to a1 r raised to n minus 1. So in this formula, a1 is the first term, r is the common ratio, and n is the nth term. So to better understand this, we're going to have an example. So we're going to use this example again. 2, 8, 32, So in this example, we're going to use the explicit form to find the 10th term. Without knowing the fourth term to 9th. So we're going to use the explicit form to immediately find the 10th term. So we're going to substitute the values. So a10, because we're finding the 10th term, so n is equal to 10. a1, meaning the first term, which is 2, and the common ratio is 4. You find the common ratio by dividing the term to its previous term. So it's 4 and raised to the 10 minus 1. So this is 4 raised to 9. Okay. So we're going. This is 262,144. So times 2, we have 524,288. So therefore, this is our 10th term.